Hello and welcome to the Fully Charged Show podcast. I'm Helen Czerski. We've been hearing quite a lot about air pollution recently because during lockdown it all seems to be changing. We've heard that mentioned on some recent Fully Charged podcasts. I've certainly noticed out and about cycling especially that the air pollution where I live in London definitely changed. It went down and then it seems to be going back up as the traffic comes back. And so lots of us have noticed changes, but what exactly is going on? What's the science behind it all? So we thought it'd be great to get a proper expert to explain it all to us, and that expert is Dr. Gary Fuller from King's College London. He runs the London Air Quality Network and he's a senior lecturer in air pollution measurement. His particular expertise is urban air quality, but he's also done a lot on the effects of pollution on health. So this is a really critical issue right now. You know, we're seeing not only have we got a massive health emergency on the go, but it's causing changes in behaviour and we have to decide what to do next. What are we going to do? How are we going to use our roads and deal with pollution after we're all allowed out, after COVID's decreased, even if it hasn't gone away? So there's lots of questions. It's all about air pollution today, and it is a pleasure to welcome Gary Fuller to the Fully Charged Show podcast.
And equally importantly, this week's episode is brought to you by a company that are really doing something to further the uptake of electric vehicles for more people. They're called CoCharger, and I really think they're onto something. Now, CoCharger are on a mission to support the 40% of drivers in the UK who want to switch to electric vehicles but have no easy way of charging them at home or easy access to a charge point. So if you use the CoCharger app, you can find a nearby CoCharger host. And if you already have a charge point at your home, you can become a host and rent it to your neighbours. So it's not like someone's coming around and just stealing your electricity, which is the first thing I thought of. I don't want people coming here stealing my electricity. That's not how it works. So they pay through the CoCharger app and you get paid for the electricity they use. So it doesn't cost you anything to have people charge their car at your house, which is really, really good. So it helps your neighbours, it helps to make your neighbourhood cleaner and greener. All the transactions are done by CoCharger, so once you've registered on the app, you don't have to do anything else. To find out more, and I really want to strongly advise you to do this because I think it's a really good idea, go to cocharger.com, CoCharger.com. It's really worth checking out. So, thank you to CoCharger for your support of the Fully Charged Show podcast. And now, let's get on with the show.
Gary, thank you so much for coming on to Fully Charged. We have a lot of interest, obviously, in future energy and electric vehicles, and pollution is one of those topics that hovers around the side of all of that. So it's nice that we can get stuck into it properly today with you. So let's get straight into the sort of foundational stuff at the start. Just tell us about the different types of air pollution that we're going to be talking about. What is this stuff made of?
Hi Helen, thanks for having me on the show. Air pollution, we talk about one thing, but in fact there are many. There are gases that are harmful to our health, and you hear in the news about things like nitrogen dioxide, where the UK has lots of legal problems. Ozone, which we normally think about as a stratospheric thing, ozone layer, UV and sunny days, but when it forms at ground level, it's very harmful to us. So they're two important gaseous pollutants. But the thing that causes most health harm is particle pollution. So these are really tiny particles in the air, mostly that form either from some sort of chemical process like combustion or reactions between different pollutants, or some types of abrasion processes, and we breathe them in. So these are the things we've dealt with all through history, originally as smoke, but now the particle mix that you breathe is a lot more complicated.
And how big are these things? Because obviously, usually we can't see them. If we leave something outside, it might get covered in grime. It might look like the pollution, and we see pollution on buildings and stuff like that. But these are too small to see. So how big are the things we're talking about?
Most of the particle pollution that does us harm has to get past your nose, through your head and down into your lungs for the most part. So we're talking about things that are really, really small. We're talking the sort of 10 microns to get most of the way down into your chest, and about 2.5 microns or below to get really into the alveoli. But we're also interested in particles that are even smaller than that, so in the nanometer range.
So a micron is a millionth of a metre, which is a thousandth of a millimetre. So this is really, really tiny.
Yeah, these are fractions of a width of a human hair. You're not going to be able to see them. And, you know, even with an optical microscope, you'll only manage to resolve the larger ones.
And of course, one of the reasons air pollution can be scary is that because we can't see it, we can't avoid it. But if you do breathe some of this stuff in, I mean, it doesn't sound good. But what sorts of things does it do to people, all the different types?
Yeah, air pollution doesn't just cause one type of harm. I mean, if we found that people that breathed air pollution suddenly broke out in green spots and died beside the road, then we'd have a real obvious attribution and we might have done something about it sooner. But what happens with air pollution is we find that when people are exposed to air pollution, it shortens their lives, really. That seems to be about the end point, and people are dying of the things that they would die anyway, so respiratory problems, heart attacks, strokes and things like that. But it's, although we've lived with air pollution from the time that, you know, humanity first sat round a campfire, it's taken a huge amount of time before we really recognised the harm. And probably one of the pivotal points is the 1952 smog in London. Have you seen that famed episode of The Crown where...
I don't watch The Crown, I'm really sorry. Have I missed out on critical air pollution education?
Well, sort of. I've seen one episode, and in it they faithfully recreate a lot of the iconic photography from the 1952 smog. The whole plot line, the Prime Minister knew anything about the smog is just rubbish. But so there was a massive smog episode in London caused by coal fires, and that at the time was just impossible to ignore the amount of people that died in our city. And that taught us that air pollution spikes, short periods of air pollution exposure, killed people. The science moved on from the 1950s, and in the 1990s we learnt that longer exposure is harmful. So there was a famous study done in the US called the 6 Cities study, where they followed several thousand people over about 14 to 16 years, and each year they wrote to them and said, "Are you dead yet?" And if the people didn't...
and they said yes. they made a note somewhere.
So if they didn't reply, then they sent out an investigator and they found out all about the circumstances of the person's death, and they knew all about them anyway. So they were able to adjust for whether they were smoking and all of those things. And as they tracked people across these 6 cities, they found that the people that were living in the most polluted cities were dying sooner. And in that way we found out that it wasn't just the spikes in air pollution that are harmful, you know, those short-term smogs, but it was the everyday exposure. The latest science is changing again, and I was part of a report by the Royal College of Physicians that looked into this and tried to highlight this issue. But what we're starting to worry about is Lifecourse exposure. So the air pollution that you might have experienced as a child, or, you know, our kids are experiencing now, will that have an impact on them throughout their lives? So if you think about, we did a study in East London where we measured children's lungs, and we found that those in the most polluted places were growing smaller lungs by about the volume of about 2 hens' eggs. Yeah?
So that's quite a lot, because, you know, lungs are big, but they're not so big you wouldn't miss that.
Yeah, it's a single figure percentage, but the kids wouldn't notice it themselves, and probably it wouldn't be clinically detectable. But if you think about older members of family and things like that, you know, as they get old, people struggle through times of flu and things like that, and lots of respiratory problems. So if we're having a generation that has smaller lungs, then are we storing up a legacy of problems to come? And it's similar as well. There's a lot more developing knowledge about, let's say, air pollution that we're exposed to before we're born as well. So that's where the latest science is really looking into these things. That does it have even larger effects than we see, because it can affect us throughout our lives.
And, you know, we should get onto the pollution itself, but let's stick with the health effects for a second. Is there any idea about what the mechanism is? Because, you know, it sounds like a bad thing. Breathing in lots of nasty particles doesn't sound good. But, I mean, are they getting into the bloodstream? Is there a sort of poison on the particles? Is it the physical, like, little bits of grit? What do we know what it is that actually causes the problem?
Yeah, I'm not. I'm more on the air pollution side than on the health side, so I can't give you a definitive answer. But the people I work with seem to be exploring a whole range of different theories behind this. Some of them is all to do with the oxidant reactions in your lungs. Others is just to do with the way that, you know, the immune system actually reacts to this invasion of particles. But what we do know more from the looking at large populations is that people that are exposed to air pollution die sooner, and they often die of the things that we would die of normally.
So it's clearly a bad thing. We don't want this stuff around. At the moment, who is most exposed to it, especially on the roads? Because, I mean, we'll be talking about lockdown a bit later, but when we think about pollution, we often think about roads. So if you're a road user, who gets polluted? Who's exposed to this sort of pollution?
Yeah, I think there's it's interesting the way in which we frame air pollution, and we've framed it in different ways through time. If you were to take, let's say, your parents or grandparents from the 1950s and ask them about air pollution, they might point to the chimneys of their neighbouring houses, and they point to them as being the problem. If you were to take someone from the 1970s and 80s and the things that were debated around that time and talk to someone about air pollution, if they were pretty switched on, they'd start talking about acid rain and forest dieback and things like that. But I think now if you were to take the average person from the streets, if we can have, you know, the person from the Clapham omnibus and talk to them about air pollution, I don't think it's very long before they would start pointing out the window of their omnibus at the traffic going past and to blame that. But air pollution comes from so many other sources other than traffic. But if you think about in a roadside environment, we think that we're protected in our cars as we travel around, but often the exposure for drivers is far greater than anyone else that you'll see in the street scene. So a street scene might compose pedestrians, cyclists and people driving, and it's the people that are driving that are normally breathing more air pollution simply because they're following the exhaust pipe of the vehicle in front.
I do. So I cycle and walk almost everywhere. And I do remember, I'm not sure if it was you or one of your colleagues, had a chat about the study that cyclists actually did a bit better than drivers because, you know, everyone thinks about cyclists being exposed. Of course, we don't want anyone to be exposed. But I did feel slightly better that it's slightly more fair in some ways if it's the drivers. It's not very nice. It's not a very pleasant thing. So, all right. So let's get on to where pollution comes from, because one of the other things before you were talking about lots of different sources of it. It's such an enormous topic to explore, but there's local pollution, which is, you know, there's an exhaust pipe in front of you, and then there's perhaps pollution that occurred 20 miles away and the wind blew it towards you. When it comes to our general pollution exposure, what's the balance between the stuff that is probably coming from right here and the stuff that is coming from 10 miles away or 100 miles away?
Yeah, and it depends on the pollutant. So the UK is having a lot of legal trouble with nitrogen dioxide. That comes mostly from traffic and mostly from diesel traffic. So that is worst in street environments, yeah? So if you're close to roads, then what you're breathing will be a lot higher than if you're in the park, which is a handy tip for if you want to think about how to best way to move around your city, you know, walk through the parks and back roads rather than along the main streets. Other things like particle pollution, well, we have particle pollution from exhausts of vehicles, from tyre, brake wear, from wood burning, which is becoming increasingly popular. But also a lot of the particle pollution, in some cases well more than half of what you breathe, is coming from a very long way away. So different pollutants react together over periods of a day or so, and you'll get air pollution from far away. So I often think about this, you know, depend on the weather, but the air pollution that we might be breathing in the UK today may have been in Paris yesterday, and tomorrow it could be in Amsterdam, and it circulates round. So controlling air pollution or controlling particle pollution and also ground level ozone is very much, you know, not just a local problem of your street. But on the other hand, if all of us were to control our local sources, we would tidy it up for everyone else. It's almost like climate change. You can say the problem is so big, air pollution comes from so far away, but if we sort all of the problems locally, we'll solve the big problem as well.
And there's some really great the data on this is amazing, and we'll talk about monitoring later, but the Copernicus is a set of satellites. It's got an atmospheric monitoring service, and they've got a little tool now where you can look at pollution levels seen from a satellite, and you can you can look at the weather map, and you can look at the pollution where it's going, and you can see it happening, like the storm's coming, but it's also bringing with it this kind of plume from some industrial area in France or Germany or something. It's really striking. It's like it really hammers home the fact that obviously it starts everywhere is local where it starts, but it lasts. How long does this stuff last in the air? That's the other question, is once you generate a little particle, off it goes on its little journey. How long is it hanging around for?
Depends on its size and depends on the weather. But as a good rule of thumb, a small, like a PM 2.5 particle could be in the air for, let's say, around a week. So something that's emitted in Eastern Europe can reach us, and we can certainly see that when we measure chemical composition of particles.
So you're one of the many things you've done in this area is you help set up and run the London Air Quality Network, I think is what it's called.
That's right.
And that is, I've seen some of these stations, and they're brilliant, because there are streets that I've walked down and you would never really think that there's any monitoring there, and then as soon as someone points it out, you're like, oh, there's a great big box here. Especially in the case of Euston Road, there's this great big wooden thing that no one really looks at until you open the magic door and you go into this little world where it's measuring pollution. So just how do you measure this stuff, and tell us a little bit about that network specifically in London.
The London Air Quality Network has an interesting history, and it was set up nearly 30 years ago, in the time when we used to have the GLC was abolished, and before the GLA, which does pan-London responsibilities at the moment, was created. And we needed some way of being able to bring together all of the air pollution efforts by the London boroughs. So us as a university at King's, we began to work together with all of the London local authorities and brought them together in a politically neutral way to look at London's air pollution. So that's one of its great strengths. The measurement sites you mainly see are run by local councils, and then we pull all of that data together to provide a London-wide perspective. How do we measure it? It's really hard to measure air pollution. I mean, we talked before about really tiny particles that you certainly can't see, and many of them you can't even detect with, any sort of conventional light detection devices, be it microscopy or anything like that. So a lot of them are done with spectroscopic techniques, and a lot of the equipment is quite expensive. And this
so that's the sort of thing where you send light. It sort of affects. It doesn't really change the colour of the light, but it affects the light that comes out of it. Basically, it leaves a signature.
Yes.
And so you can look at the signature. You send some light in. It comes out with this imprint, and you can look at the imprint and work out what must have been in there.
That's right. You can see almost a fingerprint. In terms of you divide light into spectrum with your prism. You can pick out what's in it. Other techniques that we use cause certain pollutants to fluoresce. So sulfur dioxide, for instance, will fluoresce in UV light. So you can shine UV into a sample and the sulfur dioxide will fluoresce, and you can detect it that way. Other gases, nitrogen dioxide, what we do is we mix pollutants together and the reaction actually fluoresces, so we can detect it that way.
And I have seen, my major memory of those sites is the one on Euston Road. It's got this thing in it that looks like...
It's on Marylebone Road,
actually,
Marylebone, the one you're thinking of, yeah.
I don't know, it's somewhere opposite Madame Tussauds or somewhere.
It's exactly opposite Madame Tussauds. It's a big wooden construction.
Yeah, a big thing, but which is invisible until it's like Harry Potter. But it's got this thing in it which is like an old-fashioned record player with these circular bits of filter paper, and every day it lifts off the previous piece of filter paper and that goes somewhere, and then it sort of slots another one on top. And these things are just like it's air pumping through, and they were black. I mean, I was so horrified because obviously it's not a clean street, but there's no doubt that even though a lot of this stuff is invisible, if you pump enough air through a piece of filter paper, a lot of it becomes very, very visible.
Yeah. It's not even enough air. Some of the samplers we have collect onto filter paper that's 47 millimetres, so about so big, and we take a daily sample that is similar to what you and I would breathe in terms of volume, and almost every day it's completely black. And that's even with sort of modern exhaust technologies on vehicles that are going past.
So this is all very cheerful, but the thing that it is producing is that there are now maps, certainly for London. Is this quite common? Do lots of other cities have this as well, or the countryside areas, or does it tend to be focused on who else has got this technology?
Not many cities in the UK have the detailed air pollution. Well, no other cities in the UK have the detailed air pollution maps that we have in London. So at King's, we've been working with the GLA and Transport for London for many, many years to do some really good mapping. So we map it at around 20 metre resolution. So every 20 metres there's another point where we calculate all of the concentrations. We also do real-time mapping as well, whereby we take the sort of very computationally complex modelling and then we inject in the recent measurements and we produce a real-time map. And those are on the London Air website. And the nice thing about them is you can use them to think about the way in which you travel around. So you were saying you were cycling. So you can choose your route, or if you're walking, you can choose your route. And experiments that we've done have shown that simply taking the back roads or deciding to go through a park or something like that, you can generally reduce your exposure to traffic pollution by somewhere around 50%. Depends on the route, depends on the day, but it's of that order. So, you know, have a look at the maps, give it a go if you live in London.
And so what were the big surprises when you because we're setting the scene here really for talking about the recent changes, but when you first started building those maps, was the pollution exactly where you expected it to be, or were there places where you thought, oh, I didn't know there was anything there?
There's been quite a few surprises over time. I think the biggest surprises have not been spatially, if you like, in terms of we didn't know there was air pollution there, because we've been exploring that. Some of the biggest surprises have been the changes over time. So, for instance, even around the turn of the century, everyone was telling us that new vehicles should be getting cleaner because of ever tighter Euro classes. And if you went to talk to my modelling colleagues along the corridor, all of the graphs in their room would all point uniformly downwards. And if you come into my room where we do measurements, all of the graphs over time were pointing upwards. And this for us was a massive surprise and was something we just couldn't really reconcile. If I look at the very first papers I published as scientists, we were pointing out this problem. Basically, we were scratching our heads. And that was about the turn of the century. And I don't think it was really resolved until the VW story broke and Dieselgate in 2015. So that was a real surprise to us. Why wasn't air pollution improving? And then when Dieselgate broke, that was a massive surprise to us too. The other one that surprised us has been how much cleaning up fuel can help. So around 2008, we took a lot of the sulphur out of diesel fuel. And we were talking about really, really tiny particles. These are the nanometer size. And there's a lot of them. If you think about the air you're breathing now in your home, you're probably, if you step outside in your garden, I don't know what, perhaps you're cooking or something like that in your home, but if you step outside in your garden, each cubic centimetre you breathe, so about the volume, let's say, about the size of a sugar cube, will contain maybe 2,000-3,000 really tiny particles. And if you stand next to a road, you'll be breathing around 10,000 in a cubic centimetre. But in 2008, that position was like 70,000-80,000. We took a little bit of the sulphur out of diesel and it just plummeted by about 60%. And we couldn't really explain this. Our initial thought actually was that all our instrumentation had gone wrong. This is what happens with measurement scientists, you see. It's odd that everybody believes measurements apart from the people that actually make them, and we're full of doubt.
Yes.
So we withdrew all of our equipment, we checked our calibration chains, everything, could find nothing. Well, when we found it at many places at the same time, we thought something was going wrong with the standards we were using to adjust the instruments. And then when we found it in several cities at the same time, we began to think, oh, there's something much more systemic. So that was another massive surprise to us, was just how if you improve fuels, you can improve air pollution.
So is the general picture then now, is it that particulate pollution in general is decreasing or increasing? We'll get on into the particular different types of it in a second, but overall, are we on a good trend at the moment before lockdown, or neutral or getting worse?
Generally, you would say for most particles, they're heading slightly downwards. Yeah, so the trend is either flat or slightly downwards. The main pollutant that vexes us this is from a UK perspective. Internationally, this isn't the case. So it depends on where you happen to be sitting at the time, and often we take a very UK or London-centric perspective. But if you're somewhere else in the world, then the air pollution situation is really deteriorating fast. If you go to India, for instance, or across parts of Africa, then the situation there for people is deteriorating very, very quickly. So, I mean, for us, flat or slight improvement with particle pollution. Nitrogen dioxide, London's ultra-low emission zone has made a tremendous difference there. But depends on where you are on the pollutant, I think.
So let's get stuck into some of the different types of pollutant. And because it comes up quite a bit, so I did a session on this at the last Fully Charged Live. Of course,
yes,
we were meant to have one a couple of weeks ago, but this is the Fully Charged Live the year before when we could all gather. And so one of these things that gets discussed in association with electric vehicles, electric vehicle owners like to say they are zero emission vehicles, and any air pollution scientist you come by says they are zero tailpipe emission vehicles. Right. Now explain that distinction to me.
Yeah, I actually sit on a government committee, and we produced a small memorandum actually that we've published on the government website, trying to make exactly this point and trying to tell people to be careful with the language. Once again, it's how you think about air pollution, and at the moment, our discourses, we think about air pollution as coming from the exhaust pipes of vehicles. But as a vehicle drives past, there's lots of other sources of particles. So, for instance, on your car, you renew the tyres after a time, you renew the brakes after a time, and the people that look after the roads have to renew them after a time. And these wear processes of vehicles travelling around, braking and so forth, cause a lot of particles to be emitted into the air. If you talk to toxicologists, it's unlikely that they're benign as well. So, especially for brake wear, where there's a lot of transition metals, things like copper and iron are used in brake pads and discs and so forth. These may actually be quite harmful to our health. Now, electric vehicles produce these in much the same way as diesel and petrol vehicles. They have tyres, they wear out the road. They do have some nice advantages generally in terms of braking, in that electric vehicles have regenerative braking, so that's a big bonus for them. But the wear particles are generally relate to the mass of the vehicle, and electric vehicles tend to be heavier than their conventionally fueled counterparts for the same size of vehicle. There's one quite famous or perhaps infamous study that's been published whereby they said because of their greater mass, an electric vehicle could produce more total particles than a well-controlled diesel vehicle of the same size. And I think that paper points out an important point, and it also exposes just how little we know about these processes. So does that really happen in reality? Does that happen with driver behaviour? Does that happen with the actual road conditions you get in urban areas? And I think that's a very open question. There's certainly something for the discussion we need to be having with manufacturers of electric vehicles, that they also need to be thinking about these pollutant sources that are coming from them and how they can minimise them. Fortunately, people are trying to make electric vehicles lighter and lighter to improve range, and that will help these issues as well. So they're trying to improve braking with more regenerative braking. That helps as well. So the industry is going in the right direction. But it's an important thing that I think electric vehicle manufacturers need to think about in order to minimise the environmental impact of the vehicles.
Well, someone pointed out, so we were talking to Enso when we had this session, who have we're hoping, at some point when we will get back to doing things, we want to talk to them some more about this, but they pointed out that, so they are trying to manufacture tyres that are longer lasting. They've actually got a different business model where you rent your tyres effectively, and then it's the incentive of the manufacturer to make the tyre last as long as possible, which means that bits don't fall off it. And so they think there are large improvements there. But just on the scale of sort of particulates, just because, compared with tyre, what's the sort of ratio compared with exhaust emissions from either a diesel or a petrol engine, VW1 or not, and all the other emissions, what proportion of the problem is tyres?
Yeah, so
for a conventional and an electric vehicle.
Tyres specifically, and that depends on where you're driving. But let's think about the exhaust pipe compared to the non-exhaust pipe. So the exhaust pipe compared to the wear processes. Even at the moment, because vehicles are having a lot more particle filters attached to them, and petrol vehicles don't produce many particles anyway. At the moment, the dominant source of particles from traffic is the wear processes. Yeah. So for larger particles, I think it's somewhere approaching 3/4 of the PM10 particles we get from traffic are coming from wear, and for the smaller PM2.5 it's slightly more than half. So they're already the dominant source of particles from traffic.
I've had this debate on Twitter sometimes, and one of the things that is quite interesting, so if you're having this discussion and you're listening to this podcast and you're thinking, oh, but I don't believe that tyre wear can possibly cause that many particles. So I did a simple thing. Gary can probably tell me whether it's right. I did what a physicist calls a back of the envelope calculation.
Yep.
And I looked at, so I don't have a car, but I do have a bike. So I looked at the depth of the tread when it was new and when I replaced it, and I added, approximately the mass of rubber that was going all the way around the wheel, both wheels, and then I divided it by the volume of a PM2.5 particle, and worked out approximately how many particles it would generate. And the thing is that because PM2.5 is really, 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 really small, that is actually quite a lot of particles. And so for a petrol engine, you can do that for yourself. You can compare it to the number of diesel engine, the number of particles that studies say come out of your exhaust. And so if you don't believe me, or us is what I'm saying, do that. You can do the sums for yourself, and the numbers actually do add up. If you get rid of that rubber, and if it all becomes particles, it's a lot of particles.
Yeah, it is. There are lots of studies have been done where they take new tyres, and then when people replace them, they weigh them afterwards, and they lose a lot of mass. And the same applies to brakes as well. It's a bit harder to weigh roads, but it is a lot of mass. But one of the perhaps questions that we don't understand quite so much is a lot of the particles that come off your tyres are going to be quite big, so they're going to end up being deposited nearby, and they're not going to really travel that much in the air. So what proportion of them are really tiny that you might breathe? And I think scientists and engineers have focused so much on the tailpipe emissions from vehicles, which we've been trying to control now for decades, that we haven't investigated this source enough. And this is almost one of the whole histories of air pollution. We frame it as a single source problem. We try to do something about it. We ignore all of the other sources. And this is the story with tyre, brake and road wear. So we just have ignored it. It hasn't been paid enough attention. So, for instance, tyres, there is almost no air pollution controls associated with tyres. The only thing is, excuse me, there's a certain particularly toxic set of organic compounds called PAHs, which are contained in tyres. So there's some controls on the maximum amount of them. Apart from that, there's very little air pollution controls in tyre manufacture. Some jurisdictions in the world are starting to remove copper from brakes or restrict the amount because of the copper particles, but it's something that regulators just haven't really got into, engineers haven't really got into.
So as we're finding out more, this is one of those things where now we know it's there, there's enough evidence, it's significant, we need to start adding it into the repertoire of things to worry about, which is a long list. But
so you talked about tyres that last longer, but your tyre also has to grip the road. I could think of a train tyre, if you like. They last for ages because they're metal, they're really, really hard. But you don't get much friction from them. You need friction to be able to stop you skidding. So tyres are actually, and the interaction between the tyre and the road is a really complicated piece of physics and engineering as well. And what we find is the particles of tyre wear that we measure out there are, in fact, when you look at them individually under electron microscopes, are normally composed of a little piece of tyre and a little piece of road, because they're worn off together.
So you're getting your own back on the road. It takes a bit from your tyre and you take a bit from the road, and it's
that's right. And they're all wearing out at the same time. But that's necessary so your car doesn't just slide off as it would do, on a frictionless icy road or something like that.
There is a whole fascinating thing about tyres. But anyways, I've been writing about the noise they make, and that's a whole other thing. Anyway,
that is regulated, but not the air pollution.
Okay, regulators out there, if you're listening, start thinking about tyre pollution, and inventors start inventing things that solve these problems. Okay, let's move on to a specific current situation, lockdown. So we all stopped going out, and I think almost everyone I've spoken to, so I don't know about people in more rural areas where perhaps there was less traffic to start with, but certainly here in London, my God, did you notice the difference? And actually I almost noticed it more when it came back, because there was no traffic and then there's loads of traffic because everyone's in their cars because they can't get public transport. So just let's get into what happened during lockdown. With air pollution, it's complicated, right? Some things went up, some things went down. What did happen in London? Because that's where you got the measurements for during lockdown.
Yeah, so there was a big reduction in the volume of traffic on the roads, and pretty much straight away we saw a large reduction in traffic pollution. And we saw that in the initial weeks, and it's persisted all the way through, because we went into lockdown at the last week of March. That persisted all the way through April and has persisted through May as well. We haven't looked at the data as we're starting to open up lockdown now, sort of mid-June time. So overall, for nitrogen dioxide, we've talked about that quite a few times, and it's often in the news from a legislative perspective. But if you stand alongside roads in London, that's generally reduced by about a third, which is a really good thing. But not all pollutants have gone down. So we talked a lot about particle pollution, and the particle pollution we've experienced not just in London but across most of the UK has been greater in lockdown than it was in the part of the year before lockdown.
So that is fascinating, because that is exactly not what people would expect. So where has that come from?
Well, it's a seasonal thing. And what happens is much of the particles that we breathe don't just come from traffic, they come from things like wood burning, so we get problems from that in wintertime. But in springtime we have a particular problem. Actually, I should have tried this differently, but what I often do with my students when you first meet them with air pollution is say, what's the most polluted time of year in Western Europe? And the smart ones that know their air pollution history think of London smogs and so forth, and they say wintertime. When I say no, the smarter ones still think of Los Angeles and Mexico City and summertime incidents, and they say summer. Then when you say no, they look flummoxed and generally go for autumn because it's a bit dank. But the most polluted time of year for particle pollution across Western Europe and in other parts of the world is spring. Now, we think of it as a time of like new growth, Easter bunnies, plants, flowers, all of these fresh new things. But it is that, but it's also the time of agriculture. So it's the time that farmers plant crops and they fertilise them. And a lot of the manure that farmers have stored over winter, because they can't put them on land because it ends up in rivers, they're then allowed to spread because crops can take it up. This produces ammonia that goes into the air, that mixes with air pollution from transport and industry, and gives us these massive particle pollution problems. Do you remember, I think 2014, Paris was shutting off half of the vehicles on its
every
roads.
other day or something, yeah.
So an odd even number plate scheme, and that was trying to control a springtime pollution episode. So these things have come along in the lockdown period, as they do every year. And we had 5 of these springtime smog episodes in the start of lockdown till about, I think the last one finished around 10th of May.
So were those bigger or the same as normal spring? Were they just normal springtime spikes?
They consisted a lot of that mixture of agriculture, transport and industrial pollution, but they were much smaller than we would normally expect. We need to look at this in a lot more detail since the measurements are still quite fresh, but roughly speaking they were about 2/3 the magnitude you would normally expect in springtime. But this is really interesting. So for instance, Beijing, when they had the Olympics and they've had a few other sort of big events that have put the city on show, have tried to control their air pollution, and they just didn't do it by focusing on the area around the parade or the event. What they did was they shut down air pollution sources over a massive area, hundreds of kilometres away around the city. Industry was shut down, traffic was shut down, and it was extremely effective. And I often thought, what would happen if we did that in Western Europe? And I was really quite confident that I would never find out. But suddenly, here we are, in lockdown. So it's not just London that's closed down, it's not just the UK, but all the cities around us. So in the same way that the air we might have, today might have been in Paris, tomorrow to be in Amsterdam, we've shut down emissions over the whole of that area, which has exposed the whole issues to do with farming, because that's largely happened as usual.
Because I think that is the thing that, there's these big numbers. It's sort of the same with carbon reduction, that, carbon emissions have reduced by, I can't remember, 17% or something over the past few weeks. And everyone went, but we stopped everything. Mm-hmm. And actually it really highlights that there's our daily lives, there's the things that you and I do going around on the streets, but then there's this entire infrastructure behind it that we don't see. There's where energy comes from and where food comes from, and how stuff gets cargo and all of that. And actually that is a huge proportion of all of this, all of these different of the source.
So we often frame the problem in a very specific way. Going back to the start, we so today we frame air pollution very much in the exhaust pipes and traffic, but there's our homes, there's industry, there's shops, there's power generation, which has actually changed a lot in lockdown, because the UK went coal-free for I don't know how many days, but we broke a record, didn't we?
Yeah, it was at least 2 weeks, wasn't it?
I think it's over 60 days. It's a really long period, and which is really, really good. But we can see that in the particle pollution, because certainly when there's a lot of coal burning, which we don't get so much in the UK, but when wind comes from places with coal burning, you see a lot of sulphur. We haven't really seen much of that.
So what have we learned anything from lockdown, from this? I remember saying to my department as well, we can't just switch the world off and turn it on again. But what did we learn anything from? Obviously it's still in the middle of it really, and there's all this new data is coming in. But has there been anything that's really stood out in terms of that helped, and this behaviour change made a big difference, and this wasn't perhaps as big as we thought?
I think I think as scientists that are studying the environment, we can't always set up our experiments in the same way as the lab as you can.
It's not
in a
fair,
lab.
Is it? It's just not fair.
It's just too complicated. So in a lab, what you might be able to do is set up a system to experiment on, and you turn down one of the knobs on your system. And in the environmental world, we are often spending all our time looking for so-called natural experiments. When something happens, from the atmospheric science world, maybe a road closes, or or factory closes down, and we're always looking for these natural experiments. And the best ones are the ones that change just one thing, yeah. But when it's come to the whole lockdown period, everything's changed. So it's not just traffic pollution's gone down, but the way in which we generate power has gone down. The way in which, and if we want to study it from a health perspective, regardless of the COVID issues, which have, wreaked awful sort of harm and damage to so many people and their families and lives. But there's also the way in which we've changed our lives. So everyone stayed indoors, and that affects your air pollution exposure. So I think the science that we're going to get out of it is going to be really complicated, and some of the pictures that come from it won't be as clear as you would like. But I think there's a big lesson that, just as you said there, air pollution isn't transport. We think we shut down the world, but we don't. And the only way we're going to control air pollution is to look at it holistically rather than just thinking of a single source. And for me, that's the biggest lesson to policymakers.
So looking, we're learning more about air pollution. We can see that certainly change is possible, even though it's complicated. What happens with this? So first of all, what are the things that do make it? Are there any easy wins when it comes to air pollution, or are these a big systematic changes? So what are the immediate things we could do that would make a big difference, and what are the longer term things that we need to do to just sort this out, do this properly, and not all be breathing in particles that are going to shorten our lives?
Well, I suppose the first one is, what can we do personally? Yeah, and one thing you can do is to try to reduce your exposure to air pollution, because air pollution is emitted, there's concentrations in the air, and then the health effect is by the way you're exposed to it. So one of the best things you can do is think about the way in which you travel around. As I said before, if you take a low pollution route, travel along a back road, through a park, when you're cycling, walking, then you can reduce the pollution that you breathe by about half. The next one is to try not to be so much a part of the problem. And there's a very large proportion of journeys, around I think a quarter of journeys that are done in the UK by car are less than 2 miles, and I think 60% less than about 5 miles. And if we can tackle those, then we can do a lot to help a number of things. So we can help control air pollution, we can help to control climate change emissions, we can help to change urban noise. You talked about tyres earlier, but there's a lot of people that really suffer from urban noise from transport. And also, if we do active travel, then we can do things to tackle the diseases of, inactivity, the chronic diseases of inactivity that cost our health service so much. So that's another huge win. There's some other sources that we can really tackle that we haven't really looked at in the same way. One of them is home wood burning. A lot of people, if you watch an episode of Grand Designs, you'll find that at the end of the episode they have 2 things they didn't have in the first place. Normally they have a baby along the way, and the other one that they have is their new home as a shiny wood burner. And the single largest source of particle pollution in the UK now is home wood burning. And so most of that is, it's wonderful to sit around a fire. I can't take that away from people, but that's an important thing that needs to be looked at. Then there's other things such as shipping, aircraft and things like that we pay less attention to. But,
and how about? Sorry, go on.
No, I largely finished. You go ahead.
Well, how about design? Because one of the things that strikes me that's certainly happening in London and plenty in Manchester as well, lots of other cities, is design of the city. So, there's a lot of effort now being put into sort of sharing out the space differently, potentially. What are the things that could be done there to improve, to first of all, as you say, to get rid of the pollution, and secondly, to prevent reduce exposure to it? Yeah,
so if we're going to reduce exposure, we're going to change the way in which we travel, then we have to change our urban areas to be able to do that. And one of the ways in which we can do this is to think about our neighbourhoods. There's a really good movement around 20-minute neighbourhoods. So it's to create everything that you might need in your daily and even weekly life within a 20-minute journey that you can walk or cycle. And you think, crumbs, how are we going to do that? But so many of our cities are actually built around this plan anyway. If you think about so many, small towns and cities that we had, if we ignore the suburbs that have been attached to them, they've been built around this plan anyway, whereby people would shop locally, they would work locally. And so it doesn't take such a huge step of imagination to be able to do that. I think it's a lot harder in rural areas, and it's also particularly difficult in that lots of villages and places like that are losing their shops. But restoring them will be useful. And suburban areas, I think that's a lot harder as well. But I think the 20 or even 15-minute neighbourhood area is a really, really good design principle.
And you were talking earlier about, if you do live in London. I was going to say if you're lucky enough to live in London, but given what you just said about the pollution,
I don't live in London.
Yeah, you don't. But if so there are tools, or there could be tools which help you monitor your local journeys. Are there other what's the future of monitoring in this area? Because obviously a lot of measurement, it might get done by DEFRA, or it gets done by academics like you and I. So that if you're just a person on the street, how are the tools coming down the line that will help you work out both your own exposure and your own emissions, but also where you need to avoid?
Yeah. I mean, we often map air pollution as an invisible killer, which is actually the title I chose for my book. But it's air pollution, because we can't see it. And ways to make air pollution visible would be really, really good. So London, there's lots of good air pollution maps. Other cities don't really have that in the same way. You can go online, and I do this with my students, and we each try to buy online in a sort of classroom exercise a device to measure air pollution for the cheapest amount of money possible, without pressing the buy button. And you can buy loads of sensors and instrumentation that measures air pollution. It's really unclear what they actually measure.
Because I am very suspicious of a lot of those. Because you look at them and there's this kind of techie type language, but if you actually know any chemistry or physics, it's all a little bit woolly, I think. Are there any? I mean, obviously, we're not the BBC, so perhaps we don't need the same impartiality. Are there any devices you would recommend that are probably horribly expensive?
I mean, the equipment we use, if you're measuring particle pollution, you're starting at about 20, maybe £50,000. If you want to look at the chemistry of it, you're looking at 150,000. You have to plug it in. It requires a lot of TLC. You're not going to be able to do that yourself, and also you're not going to be able to track your air pollution exposure as you move around. So the whole sort of goal of sort of citizen science or personal measurement, whereby you can see the air pollution you're exposed to, is a really, really good one. But it's fiendishly difficult to do because the particles are very small and the concentrations of air pollution, despite the harm they do, are really small. We're at the parts per billion molecules in the atmosphere that you breathe. A lot of the technology that you can buy out there at the moment, from a small sensor that you could buy online, generally is something that's been created from an industrial environment. So if you're working in a dangerous indoor factory environment or something like that, you need to know if gas X is leaking and everybody has to run. And it's quite easy to create a specific sensor in an indoor environment that's quite well controlled to measure a pollutant. If you take that into the outside world, where we've got varying levels of temperature, we've got wind, we've got humidity, before you even look at the cocktail of air pollutants rather than just measuring one dangerous one, then it becomes really, really hard. And that's the reason why the technology struggles. What we've done is that people have taken these types of sensors and they've strapped a lot of post-processing around them to try and get around this, but they really struggle. We're yet to find something that we would really trust.
So the message is that if you're lucky enough to live in a place which has a good air monitoring network set up by the city, the council or a university, use their very expensive sensors to look at their maps, and that's probably the best chance you've got to find out what's really going on.
So in London, we hourly we recast this map of London's air pollution, and I think we do better than the small sensors would do. But also there's kind of a justice angle here. We're all carrying around a mobile phone, and if you just look on a web page, you'll be able to see air pollution. And if you look on the London Air web page, you can lay this over the maps you might be using to walk around to make those decisions. It can tell you about air pollution in a spot before you arrive at it, rather than measuring it. It's only when you get there. And I think you could do a lot better with these, and we don't want everyone to have to spend a few £100 or £1,000 on a piece of personal measurement kit. It's just not right. Okay, we need to solve the problem, but it's a lot easier just to produce high quality maps that people can use, and they've far greater utility, I think.
Brilliant. So we're pretty much out of time. Just before we finish, if Gary ruled the world for one rule on air pollution, What would you change tomorrow? What's the one thing that you think would make the biggest difference or matter most to improve this situation?
I know I say that transport air pollution isn't the biggest source. I think if we can change the way in which we travel, there are so many other win-wins that come with it, then that's where I would focus. So I would focus on moving towards active travel, so walking and cycling, rather than a lot of car journeys or even journeys by public transport. So that's where I will put my solution. Someone asked me, interestingly, a journalist, they said, what will be the vehicle of the 21st century, in one of these little googlies that get thrown in at the end of an interview. And I thought, well, the answer I would really like would be the bicycle.
I'm in for that.
I certainly am too.
Brilliant, great. Well, thank you so much, Gary. That's absolutely fascinating, and I'm sure we'll be doing more on this topic in Fully Charged in the future. But thank you so much for your time. We really appreciate it.
Thanks for having me along.
I hope you enjoyed that conversation. I certainly did. There is so much stuff in there, so many little complexities and nuances to all of this stuff, but we're breathing in the atmosphere all the time. You're breathing it in right now. It's literally inside you. So all this is really worth knowing about, and especially some of that stuff at the end about air quality measurement. Locally, loads of people would love to have their own sensor, and if it's not really going to work in the near future, we should probably all know that. So that was all the air pollution, all your fully charged air pollution knowledge for this week. If you'd like this and you'd like to support us, please subscribe to Fully Charged on Patreon. You can subscribe to the Fully Charged podcast, and there is loads of stuff on the fullycharged.show website, articles and podcasts and episodes and all kinds of things. So do have a look at all of that. And if you have been, thank you for listening.